Alright, welcome back everyone. Today I wanted to come back to the topic of the DSOMM and more specifically to the DSOMM Level 2. And it's going to be a shy but a long video because we are going to go through all the circle of the Level 2 and I will give some comments in terms of what is what to just make it easier to understand and digest and maybe prepare yourself. I will leave the notes about each of those items in the description below, so please check it out. And before we even begin, first of all, like and subscribe the video and grab yourself a coffee. I think that will be helpful and useful. With that, let's jump right into that. And just to remind yourself, the DSOMM is basically a framework to say that you are doing the DevOps in a secure way. So right now we are looking at the level 2, which would be the adoption of basic security practices. It might sound like not a lot, and every respecting organization and company would probably want to focus on level 3. But before you go to level 3, you need to just cover your bases and do it in a step-by-step basis. And before level 3, you need to get level 2 done. I might, as previously, and maybe I will come back even to level 1, just add additional videos about each individual items or some of those individual items, so please stay tuned. Now, for the build, there are 3 items, as you can see over there, and basically they are pretty easy. And the first one is building and testing artifacts in a virtual environment. If you are using any sort of the CI/CD tool, like Azure DevOps or Jenkins or Azure GitHub Actions and so on, they actually run all of those operations on a virtual agents, and those agents are not long-lived, apart from Jenkins, where you have it as a virtual machine, but still it is a virtual environment, so that would be taken for granted. Then, pinning of the artifact, it is another interesting one, and basically what you need to do is to say that after you build your application or your code, you need to assign a tag to it, and then just make sure that you are using this specific tag and not really relying on using the latest tag pretty much. So once again, it's a common sense, and it would be taken for granted, I assume, for most of the organization right away. The next one is a little bit more interesting. So you need to provide the SBOM of the components for your application, and that SBOM it actually goes down into the direction of each of the applications. So if you are building your Java applications and all of the dependencies of your Java application and frameworks and so on, and what I can recommend, and that actually goes a long way for that whole DSOMM thing. There is such thing, and I mentioned that already, I believe, a couple of times, as Trivy. And Trivy from the Arco Security, it's an open source security scanner, and it can do a lot for you. Just in terms of it will generate additional confidence in your code and how you do things. But additionally, it will cover a lot of those items from the DSOMM. So if you use it, you can just gradually build up and use additional features from Trivy to cover all of those bases. And I would recommend doing this. And getting back to the SBOM of the components, Trivy can do that and can generate it. And my personal thing, I would probably generate it in the Cyclone DX format, and then you can visualize those as well. But from the requirement itself, you don't need to visualize it or do it in any way, and the only thing you need to have it is that you need to generate the SBOM. So when the auditor will come, he will need to show that, here is my SBOMs for my latest build or something like that. and those SBOMs can be just pinned as build artifacts during your build stage. Uh, that was about the build. Next is the deployment, and here it is actually a little bit more of a documentation process as well. And with the DSOMM, you will see it's a thing that can repeat itself again and again. A lot of those tasks, they actually just require to have a documentation or the process in place, and not necessarily the technical implementation. And yeah, with it, the first item on that list is to have a defined decommission process. And basically, you just need to document somewhere, maybe on Confluence, maybe even in a README file of your infrastructure code, how are you going to decommission things. And even if you don't plan to do that often, if you, for example, run the applications that should stay up and running 24/7, still you need to just document how you're going to decommission things if the need arises. Next is the environment-dependent configuration parameters and the secrets, and it can be a lot of words, but pretty much what it means is that you shouldn't hardcore any secrets and use something like, and I need another sip of coffee. Sorry for that. So basically you need to use something like a Hashicorp Vault or the Azure Key Vault to store the secrets and the configuration for each of the environments, and the application should just read those specific values and not have them hard-coded in the code. That would be the easiest approach. Next is the evaluation of trust for used components, and this is actually, once again, some sort of a generic documentation requirement for this. And you, as any big application, you have a lot of dependencies, and what you need to do is to have a whitelist or just a policy somewhere in your organization what you consider a trustworthy dependency and what not. So you might just say that Spring, for example, is a well-known framework and you trust it, but something like Hibernate, it is a very suspicious thing, and you don't want to use Hibernate because of that. So that's just how you are going to evaluate each of the components that you are going to use, and if you trust it or not. And that's a documentation task, as I said before. Next is the inventory of production artifacts, and for this one, it could be argued that if you deploy all of your code using the pipelines, then the pipelines themselves can serve as a documentation, and basically everything that you have in your main, then it would be deployed to production. Or you might have an additional tag on your Git history, on your Git repository with all of the specific commits that were deployed to production, and you can generate the inventory of your artifacts that way. But it is, as usual, with DSOMM and with the security stuff, it is up to discussion pretty much, and you can just understand it as you want, and then just need to convince the auditors when they come that you actually have this, if you want to present it as something that you have. Next is the patch management section. And here we want to have, first of all, the automated merge of automated pairs. So you remember that over here, for the level 1, we had automated pairs for patches. So the system should automatically detect that you have some outdated dependencies, maybe with vulnerabilities, maybe they are just old, and they needed to be updated. The pull request for those patches should be created in an automated way. In the second level now, we need to automatically merge them. So it could be that you just automatically assign the autocomplete tag on the pull request, and that would be it, pretty much. And to have that confidence, you actually need to obviously run a lot of automated tests to be able to merge those pairs. Otherwise, you can merge them just blindly but it's not the best practice, I would say. Next, the nightly build of images, and to be more precisely, base images. And this is a very interesting task, and I definitely want to create a video, separate video about this. It could be, or actually, this one and the next one, the reduction of the attack surface. Those two together, they basically say that you need to implement something like distress images as base images, and on top of that, to build those distress images that you will use as your base images on a nightly base. That is a very interesting topic for sure, and the distress images are basically the minimal stripped down versions of the publicly available images where you will define what are the dependencies that you want to have, and I would highly recommend to implement this. It is a lot of fun, I would say. So please stay tuned for the next video on that topic. And the last one is a usage of maximum lifetime for the image. So pretty much when you build your application over here in an automated way, it should have a maximum lifetime. And that means that after a certain period of time, you definitely want to rebuild the application and redeploy with all of the patches applied, with new functionality potentially, or just to reset the memory. Uh, that one is once again up to a policy of your organization, and you can easily say that the maximum lifetime for our image is 1000 years, and then you never need to redeploy it because of this requirement, and only when you work on the code base, which is can be good. Next is design, and that will be the first of the culture and organization quadrant of things. And the first one is that information security targets are communicated. And the good thing about this is it is once again just a process thing. And if you have something like ISMS, so information security management policies, and something like the IT phishing campaigns and so on, uh, being organized in your organization by the IT, most likely, not by the development department, then you are pretty much covered on this one. And if your employees, co-employees are aware of what are the security targets and why you don't want to run the application that is not secure, then we are good. And this is an easy one. The education and guidance. First of all, each team needs to have a security champion, and the security champion is a member of the team who is just completely focused on responsibility to build a secure application, and can promote those good practices how to do the code in a secure way. And it not only affects the code itself, but also all of the communications and other targets, and have secure pipelines and so on. So that's the goal of having a security champion who would be a person who would just set aside a certain amount of time to work on security tasks and processes, including documentation too. Next one is to have a regular security trainings for all, and yeah, it's as easy as it can be. And then the security training for the security champions, so a little bit deeper because they need to provide more context for the rest of the team. And the last one is a reward of the good communication. It can be some sort of a gamification, or just to. It's a basic idea that for team to work coherently in a good way, they need to communicate. And for example, uh, as I mentioned, the tech exchanges in one of my previous videos. Tech exchange is another example of a good communication where you would just develop something or provide a concept on a secure code reviews, for example, and that will be the next one. And then communicate it clearly with the team, and have a buy-in from the rest of the team, and maybe then even from the rest of the company, to create it as a policy that will affect the whole organization. And speaking about the code reviews, the last one is a security code review. So on top of the regular code reviews that is performed hopefully by everyone and just part of your regular pull request process, you need to consider the code if it is secure enough or not. And that can be as easy as just to have a OWASP top 10 being tested automatically, but it could be as manual as just have a list of items that you don't want to allow in your code base. And the person who is doing the security code review or just the code review needs to be aware of what are the common gaps and vulnerabilities that can be introduced. And for example, if you have an input parameter to your application and then this input is directly used in your SQL query, it's not good practice and you need to sanitize that input and even better just use the parameters in your queries instead of building the query string as concatenation of strings, something like that. Uh, Next, the process, and this one is basically to have some security stories in your backlog defined, and that would be your determination of your protection requirements. So when you build your application, every now and then there would be a new thing that would come up as a security gap, and that will definitely happen. So it could be as easy as just a new CVE being uncovered in your code base, and then you could have a story to just fix it from your dependencies, for example, or from your actual code base to just strengthen the security of your application based on the latest recommendations. Because we all live in a non-perfect world, and you will start your application as a most pragmatic and a quick way. But then when you build up your application, probably you would need to introduce additional security practices and things to cover yourself. And that will mean additional work and additional requirements. And those requirements need to be tracked through backlog, for example, in your Jira. Okay, next is application hardening, and now we are getting into the implementation quadrant of the whole thing. For the application hardening, here we need to have the app hardening for level 1 and completely implemented, compared to the level 1 of the DSOMM, where the application hardening level 1 needed to be implemented only for 50%. Now we need to implement it fully, or at least how it is said in the description over here somewhere. Let me find it. Yeah, here implement 95 to 100% of the recommendations. And here I have another recommendation for you in terms of this one. You can use something like this checklist for the ASVS from the AWASP, and there are a lot of abbreviations, I know. And this ASVS checklist, basically you can download as an Excel spreadsheet, and it is very small, so let me zoom in quickly and hopefully you can read. So here you have 3 levels actually for the ASVS that you need to implement for this checklist, but for the DSOMM level 2 you need to implement only level 1. So what you can easily do is just to apply a filter on ASVS, set it to 1 only, and go through that list and say if it is valid or not valid. There are a lot of tabs over here, and you will need to go through all of them, and that's a perfect task for a security champion, actually. Yeah, to spend some time reading through all of that and creating stories in your backlog to fix up those requirements if they are not met, or if you just want to skip them, that's perfectly fine. Once again, if you think that those are not needed, and that would be it. So quite easy, time consuming, but useful. That's what I wanted to say. Next is containers running as root users, and that will actually go back to the base images that you are building, and it's a good idea to never run your application as a root user and instead to create a separate user in your container with a user group assigned to it with just limited permissions, maybe just to execute your application, maybe to have additional write permissions to your log folders or whatnot, and so on. But basically, that you need to define what kind of permissions are required for the user, and that user is actually a context for your application to run. Basically, what they need to have to run your application correctly, and it's nothing to do with the end users that are using your applications, if it makes any sense. All right. Next is development and source control. And here we circle back to the pull requests. And now we basically need to say that the pull requests are required before merging. And you need to actually, the best way to implement it is to have branch policies in place where you would say that how many people need to review the pull request, who they need to be, and what branches are fine, what branches are not. Because if it is something like a feature branch, it makes no sense to restrict commits to it. But if it is a main branch from which you deploy to production, then definitely the policy needs to be in place and the pull request, pretty much all of the changes to the branch needed to be done through the pull request, and that's it. And we are going to include the security code reviews into the mix here as well. Next is the infrastructure hardening, and as you can see here, we have a lot of things to implement, but worry not, those are quite sensible, and most likely you have them already in place. The first one is that applications are running in virtualized environments, and once again, in all of my examples that I was given in the channel and in my courses on Udemy, and pretty much that's quite a common scenario anyway. You are going to run the applications and build the applications as images, and then they will be executed somewhere, but that would be a virtualized environment. So the pretty much the requirement of it is that you are not running them on bare metal, and that if you are using cloud providers of any sort, that would be given for granted. Then backups, you need to have a periodic automated backups in place. And once again, for your applications, you probably don't need them, I would guess, because you should be able to restore your application by just redeploying your app, and the application should store all of its state into something like a database or the storage. And then for the databases, yes, you would need to implement the backup strategy in place. So how often it is done, and how to restore them, and so on. And even better if you have a periodic backup restoration drills where you can just verify your backup process. Next is the baseline hardening of the environments. And here you just need to document. Once again, it's a documentation task to say what is your baseline hardening of the environments. And I would highly recommend to use something like Azure Defender, and just say that from the Azure Defender you want to have at least or at maximum medium threads in place, and nothing more than that. So all of the high and critical ones should be fixed as soon as possible. And that would be your baseline security for your environments. And another solution for Kubernetes, for example, there is a hardening practices, and it is referenced even over here, to have something like this one that you could implement. Next is isolated networks for virtual environments, and that's pretty much that you need to have your virtual networks, and they need to be contained and not just publicly available. Pretty much you want to have definitely want to have a separation between your dev non-prod and production networks, but on top of that, it's even better if you have a separate virtual network for each of your applications, and then just define what are the peering rules for the other applications and allow only the required traffic as needed. Next is MFA, and once again, most likely, and I really hope that it is implemented everywhere already, you use your multi-factor authentication to grant access to pretty much anything. If you use Azure or AWS, then you should have a second factor of the authentication. So, for example, the Authenticator app, and the same would go for your tools that you use to develop the application. So to access GitHub or the Azure DevOps, it is preferred to have a second factor as well. So not everyone should get into your application, into your organization code just by guessing your password and email. Next is the usage of the security account, and basically that means over here is that you need to use a separate account for that would be dedicated for security activities. And you can speak with your IT just to create a secondary account that would be used to try and break things and run all of the scans as a completely clean account without extra permissions that developer account most likely have, and that would be easier to run a clean security scan pretty much of your application. That's why it is there as a requirement. Next is encryption at rest. And let me elapse stuff so it is a little bit more visible. So next is encryption at rest, and once again, by default, it most likely implemented for your cloud provided services. But if you have some sort of a interesting setup, then you would need to cover it yourself. But for regular cloud providers, you will have it out of the box. Next is the usage of separate test and production environments. So, as I said, it is a very good idea to have non-prod and prod, and I would go even one step further and have actually three environments at the very least. The development one, where developers deploy the code immediately and can test it for functionality themselves. Next would be the UAT or the QA environment, where you would have the code and the functionality of your application accepted by the stakeholder. And finally, you would have a production where you would deploy it for your end users. So that would be my recommendation. And the next one is virtual net environments are limited, and basically it means that you are not running something like Kubernetes pod without any restrictions, so it doesn't eat up all of the available CPU and memory, and that your application doesn't have auto-scaling enabled up to no limit. That even if you would auto-scale your application, then it would be limited to X number of instances instead of just any of them. Quite easy to achieve, and it is mostly about your budget. And if your applications would eat up resources of other applications developed to the same infrastructure for some reason, by design, I mean. All right, we are about halfway through, so I'm going to make a cut over here, and I will continue with that list to finish up the circle in the next video. So please stay tuned, like and subscribe this video if you enjoyed it, and leave your comments with your thoughts down below. See you soon.